All right, so a function application. All this means is we are going to take situations, apply what we know about functions in order to answer some questions about it. All right, so example one here says you're buying concert tickets that cost $15 each. You can buy up to 6 tickets. We're going to write the amount in dollars you spend as a function of the number of tickets you buy. And we're going to identify independent, dependent variables, and then also identify domain and range. Okay, a lot of those, several questions within that. A lot of them go together. Okay, so first, writing the function rule. We're always going to do that by starting with y equals. Okay, we are buying concert tickets that cost $15 each. Okay, what word does each tell us to do? What operation? Multiply. So if we call x the number of tickets, we would have y equals 15 times x, and that will give us our total cost. Okay, so there's our function rule. Now that we have that, we're going to fill in the table. Now, process here, you don't always have to fill that in. That's just an area if you want to do it by hand and show your work. Okay, you can use a calculator for this if you want to. But we're going to say 0 tickets, 1 ticket, 2 ticket, and it said we can buy up to 6 tickets. 3, 4, 5, 6. Okay, if you wanted to fill in the process, this is what it would look like. 15 times 0 would be 0. 15 times 1 gives a cost of 15, and so on. See the pattern there? Okay, we can also use a calculator. If you go to your calculator, you go to y equals is this top left gray button right there. We can type in this function, 15x. So you type in 15, and the button we use for x is just to the right, this right of the green button. It has an x, a t, a theta, and an n on it. If you hit that button, it'll give you an x. Okay, once you have that in the calculator, you can go look at the table. If you look above the top right gray button, in blue it says table. So to get that blue function, you have to hit the second button, the blue button, and then graph. So there's the y's we can fill in for those corresponding x's if you want to use the calculator instead of calculating them by hand. So we had 0, 15, we already had those two. Then we have 30, 45, 60, and so on. What are we going up by there? What's the pattern? Yeah, we're going up by 15, which makes sense, right? Because each ticket costs 15. Okay, so there's our table. We don't need to go higher than 6 for x because it says we can only buy up to 6. So far, we wrote the function, filled in the table. Okay, now they want us to identify independent and dependent variables. Okay, here's a little trick you can do with the way this sentence is worded right here, where it says write the amount you spend as a function of the number of tickets you buy. When you see these words right here, as a function of, cross them out and replace them with the words depends on, because it means the exact same thing, and it also answers that question. So if I now read it and it says, write the amount in dollars you spend, the dollars you spend depends on the number of tickets you buy. Okay, so the independent is the number of tickets you buy. The dollars spent is depending on that. So the number of tickets is your independent. So number of tickets bought. Our dependent is the amount you spend, or you could call it total cost. I'm going to put amount spent because that's how the question words it. There's our independent, dependent variables. Another way you can think about it is, we've talked about before, when you have a function, x is your independent, y is your dependent. So just think of what x and y are representing here. X is representing how many tickets we're buying. So that's our independent, number of tickets. Y is representing whatever that cost is, the total cost. That becomes our dependent. Okay, so we've identified those, identified domain and range. That's probably the easiest part. We have our table here. Here's our domain, our x's. There's our range. If I ask you to identify those things, you can do it just like that. You don't have to write it out down below. So last we have is to make a graph out of that. So in other words, just plot those points. So 0, 0, 115, be halfway between 10 and 20 there. 230, 345, and then we keep going up by 15. So 460, 575, and 690. Okay, now do not draw a line and connect that. Okay, if you draw a line and connect it, that means you can do such things as buy 1.5 tickets. Can you do that? No. This would be a discrete function. It's not continuous. You can't draw that line and connect it. You just need the points there. Any questions there? Okay, so there's a lot of questions within that. Biggest key is write your function rule, complete your table, and then you can usually answer the questions about dependent and independent variables and domain and range after you have that. Okay, so let's look at another one here. You have 10 quarters that can you use for a parking meter. Each time you put 1 quarter in the parking meter, you have 1 less quarter, which makes sense, right? Use a quarter, now you have 1 less. So blank is a function of blank. So on these types where you have to fill it in, a lot of times the next part will answer it for you. They even do this on STAR a lot. Write a rule for the number y quarters that you have left as a function of the number of x quarters you have used so far. It's the same wording we have up here. So the quarters you have left is our first blank. Remember we talked about you can replace as a function of with depends on. So the quarters left depends on the quarters used. Every time you use a quarter, we have 1 less quarter. So the number of quarters you have left is a function of the number of quarters you've used. Okay, so if we want to write a function rule now, once again, start with y equals. They give us a starting value here. What are we starting with? 10. So we're starting with 10 quarters. And it says each time we use 1 quarter, we have 1 less quarter. So what operation does it sound like when you're using a quarter or taking away a quarter? Subtraction. So we're going to subtract x, which is the number of quarters we have used. So our function rule is y equals 10 minus x. Starting with 10, taking away 1 each time we use 1. Okay, so we can fill in our table. This time we're going to kind of go in reverse order. Or we can start with 0. We'll do that. So do 0, 1, 2, 3, 4, 5, 6. And we go ahead and make rows up to 10. Just since we have 10, might as well do that. Okay, this y column, a little easier to fill in. If I started with 10 and I've used 0, how many do I have left? If I started with 10 and I've used 0 of them, I still have 10, right? If I started with 10 and I used 1, I now have 9. If I used 2, I now have 8, and then so on. 6, 5, 4, 3, 2, 1, and then we would be out of quarters. Okay, so domain is all our x's. Range is all our y's. So there's our domain and range. Now this one doesn't ask us to, but if we want to identify independent and dependent variable, just to get in the habit of doing that, what's our independent variable here? What do you get to choose? How many quarters you use or how many you have left? You get to choose how many you use, right? So quarters used is the independent. The dependent would be amount of quarters left. Which independent dependent is good to review over because that is on your quiz today. And then last, make your graph there. So at 0 quarters used, we have 10. So this is going to create a line that's going down from left to right because we're using them up. When we use 1 quarter, we have 9 left. 2, we have 8, and then so on. 5, you have 5 left. 6, you have 4 left. 8, we have 2 left. 9, we have 1 left. And when we've used 10, we have 0 left. So there would be our graph. Okay, once again, this would be discrete. Can't use 10 and a half quarters. Can't break half a quarter in half and put it in a meter. Good there? All right, turn it over. You have $100 saved, and you plan to save 20 each month. So we're going to write a rule for the amount saved in dollars as a function of the number of months from now. So writing our function rule first. Start with y equals. Do we have a starting amount here? An amount we've already saved, 100, yeah. So we're starting with 100. We're going to save 20 each month. If we are saving, are we adding or subtracting from the 100? We're adding, yes. And then 20 each month, just like earlier, each tells us to multiply. So 20 times the number of months, we'll use x. So your function will be y equals 100 plus 20x. Okay, so if we want to fill in our table, if we save for 0 months, how much do we still already have? We still have the original 100. If we save for 1 more month, how much are we going to have now? 100 plus 20, so you'd have 120, right? And I'm trying to just get y'all to think through this. You can just put in the calculator if you want to. We say for 2 months, 2 times 20 is 40 plus 100, 140. And after 3 rows, you should be able to tell what this is going up by, what the pattern is. What's our pattern? It's going up by 20, right? So we need to go up to 12 months from now. 3, 4, 5, 6, 7, 8, 9, 10. We'll make 2 more rows. 11 and 12. So our y column's going up by 20. So we'd have 160, 180, 200, 220, 240, 260, 280, 300, 320, and then at 12 months, we would have $340. And that answers this last question. How much will you have saved altogether 12 months from now? So at 12 months, we save $340. If we want to identify independent, dependent, domain, and range again, domain and range is the easy one. Just label your x and y's. So domain and then your range. Okay, for your independent variable here. So the amount saved as a function of the number of months from now. So amount saved depends on the number of months. So you're independent. What are you getting to choose? The amount you save or the number of months you save? The number of months. So the independent is the number of months we save. And then our dependent would be the amount saved. Anytime you're dealing with money problems, whether it's saving or spending, the dependent is always going to be the total saved or your total cost. It's the total amount of money. That's always going to be your dependent. It's going to depend on some other factor. And then last, make your table or your graph. So at a 0, we're at 100, so we're starting right here on our y-axis. And then at 1, we're at 120, 2, 140, and so on. And you can stop when you get to 8, 260, just because we run out of graph space. All right, one more we're going to look at, and this one, y'all are going to come up with the scenario. So it says, describe a real-world situation that models W is equal to 8H. And then go through the same process again, and identify independent, dependent variables, and so on. Okay, so we need some situation where we would be getting a total by multiplying 8 by something. It could be anything. What's that? Think of it this way. What's a variable that H might represent when it talks about, think of money, a job. Hours are going, right? So we could say maybe making $8 per hour. And what would W represent there in that case? Your what? Your total what? Total amount you've earned, right? Okay, there's a scenario that works. So we could say W is your total earnings. For making $8 per hour. Okay, so there's a million different scenarios you can come up with. Usually, if you talk about money and hours worked, that's a pretty easy one to come up with. But you can come up with anything where you're multiplying 8 by something, it gives you total. You could make, say, you're doing 8 math problems per hour, and then W would be the total number of math problems you did after so many hours. You can make it really anything. Okay, so we got our function rule. W is equal to 8h. Just know if they use you different variables, if it makes more sense to you, you can rewrite it with a y equals and an x for the other variable, since our table has x's and y's. Okay, so under that scenario, if we work for 0 hours, how much money are we going to make? That'd be 8 times 0, which would be 0, yeah. So if we work for 0 hours, we're going to make $0. We work for 1 hour, we're going to make 8, yeah. And we'll just fill this in up to how far it goes, 3, 4, 5, 6, 10 hours. So after 2 hours, we make 16, and then 24, and we just keep going up by 8. So you have 32, then 40, 48, 56, 64, 72, and then after 10 hours, you would have made $80. Okay, so your domain would be your x's, so I'd label that. Range would be your y's, and then we would need to come up with our independent, dependent variable. Okay, so in our scenario of you're making $8 per hour to get a total cost, what would be your independent variable? What is H representing here? The hours. So the number of hours you work. That would be independent. You or your boss gets to decide that, the number of hours you work. So your dependent would be your total earnings. Remember what we mentioned earlier. Anytime you're dealing with a money problem, some sort of total is always your dependent, whether it be total cost or total amount saved or total earned. That's always dependent. Okay, and then if we make our graph, so at 0 hours you made $0, 1 was at 8, 2 was at 16, and then so on. So you get a graph that looks like this. So it'd be going up. So notice on all of those we made, all of them either had to do with, these two on the back was amount total saved or total earned. Those created graphs that were going up from left to right. If you look at this last one on the front, we were using up quarters. That created a graph that went down from left to right. Okay? Perfect. Yes, thank you. All right, any questions with that? That's what your homework's going to look like. Okay, I'm going to give you the homework. That way, as soon as you finish the quiz, you can start on that. And then I'll pass out the quiz and explain a couple things on that to you. Homework pretty much models exactly like the notes were, just different problems. We have 4 total. You get that, put everything away for now. You get that back out after the quiz.